Solving systems by elimination. Now, how do you solve a system by elimination? Well, we got to think of a couple of things. One thing that's going to help us is if we can remember that when we eliminate a term in an equation, in other words, when we're solving for a variable, such as solving for x, we use inverse operations to help us to do that. So why we use inverse operations is because it makes it go away. If we add the opposite, that term disappears. Well, we're going to use that same idea of inverse operations when we're using solving systems by elimination, because in elimination, we're basically going to add the equations together so that we will be able to eliminate a term. So our purpose is to add equations together, get rid of one variable so as to solve for the other variable. And we must remember that when we are solving a system, our answer is an ordered pair. It is a location. So let's take a look at this problem here. We have x plus y equals 5 and 2x minus y equals 4. Well, if we straight up start adding these equations together, we can see the y's are opposite of each other, a positive y and a negative y. What that'll happen is that they will cancel each other out if we were to add these together. X plus 2x will give us 3x. Since there are no y's, we don't have to worry about that. And 5 plus 4 is 9. Now we have an easier equation to solve. By dividing both sides by 3, we find out that x equals 3. And again, since we're building an ordered pair, we know that x is 3, and we're going to figure out what the y is. We go back to any of these equations from the original. It doesn't matter if we take the top one or the bottom one. So let's take the top one. 3 plus y equals 5. And here what we're going to do is we're going to subtract 3 from both sides, and we find out that y equals 2. So our ordered pair then becomes the location of 3, 2, where these two lines will cross. We'll do it again. Here we have 3x minus 3y equals 6 and 3x plus 3y equals 0. Again, the y's are opposite of each other, so we could go ahead and add straight up right now. 3x plus 3x is 6x. The y's, again, like I said, would go away, and 6 plus 0 is 6. We would divide both sides by 6, find out that x equals 1. So as we build our ordered pair, 1 goes in the first spot, and now we look for y. It doesn't matter which one of these we go back to. I tend to choose the ones that have no negatives or smaller numbers. So what we'll do is in place of the x, we're going to put a 1 in that place. So we'll have 3 times 1 plus 3y equals 0. And then we're going to reduce it. We're going to subtract 3 from both sides. Get 3y equals negative 3. Divide both sides by 3 and find out that y equals negative 1. So 1, negative 1 is our ordered pair where these two lines cross. Now sometimes we'll have lines that won't be set up as nice as these two problems. Let's take a look at this one. 4a plus 7b equals 11 and 4a plus 6b equals 10. Now if we were to add these up just the way they are right now, we'd end up with 8a plus 13b equals 21. And we didn't lose a variable, so let's get rid of that and let's think. We could get rid of the b's, but I would have to change both equations in order to do that, multiplying through. We have to remember our skills about multiplying through and changing an equation. Well, here I have 4a and 4a. If I multiply this bottom equation through by negative 1, I can change this so that this would be a negative 4a, so I could add them and it'll go away. So let me rewrite this equation after multiplying through by negative 1. Becomes negative 4a minus 6b equals negative 10. And the one on top would be 4a plus 7b equals 11. Now I can add these two equations together. We can see that this will go away because they are opposite. 7b minus 6b is just b, and 11 minus 10 is 1. Now a and b works the same as x and y, so b would go into the second spot. Then we always go back to the original equations when we want to try and find the other part of the ordered pair. Doesn't matter which one we take. I'm going to take the bottom one because the numbers are just a tad bit smaller. So 4a plus 6 times 1 equals 10. I'm going to simplify that 6 times 1 to be 6. Then I'm going to subtract 6 from both sides. And then I'll divide both sides by 4. I find that a equals 1. So again, I have my ordered pair that shows where these two collide. Let's look at another one here. Here I have 7x minus 5y equals 76 and 4x plus y equals 55. Well, again, if I go add them straight up, I'm not going to be able to get rid of the x or the y. Here, to get rid of the x's would cost me a little bit more to do and work. Here, I can see that if I multiplied everything by 5, I would have a positive 5y and a negative 5y, so my y's can go away. So I'm going to do that change. That would give us 20x plus 5y equals 275, I believe. And then this one is 7x minus 5y equals 76. So now when I go to add them together, 20 plus 7 is 27x. The 5y's will go away because they're opposite. And when I add this together, I get 351. Now I'm going to divide both sides by 27. And when I do, I find that x equals 13. So in my ordered pair so far, I have in the first spot the x, I have a 13. So then I need to go back to the original equations, choose one of them. I'm going to choose the second one here. 4 times 13 plus y equals 55. 4 times 13 is 52. So I'm going to subtract 52 from both sides. That way it'll get the y alone using inverse operations like we talked about earlier. And then we know that y equals 3. So our point location where these two lines cross is at the ordered pair 13, 3. Now what happens if you can't make a single change? So here we have 5x plus 3y equals 2 and 3x plus 5y equals negative 2. Well, since 5 cannot go into 3, we're kind of stuck and we're going to have to change both of them. So it doesn't matter if we get rid of the x's or we get rid of the y's. I'll get rid of the y's this time. So we're going to change that. Means I want to have this to be 15. So I'm going to multiply everything on top here by 5, and here everything will be by 3. Now that doesn't get me to an opposite sign. That gets me to get them both positive 15s. Now I need one of them to be negative because I need to change the sign to be a negative. So I'm just going to make the bottom one negative. Doesn't matter which one you choose, just as long as one of them so that they have opposite signs of each other. So on top that would give us 25x plus 15y equals 10. And on the bottom we have negative 9x minus 15y equals positive 6. So when we get rid of that, we know that the y's are now gone. 25 minus 9 is 16. X equals 10 and 6 is 16. We're going to divide both sides by 16. And here we have x equals 1. We're going to take this 1 and we're going to plug it into either of these. I'm going to take the top one. 5 times 1 plus 3y equals 2. Reduce this, 5 plus 3y equals 2. Subtract 5 from both sides. Find out that 3y equals negative 3. And then divide through by 3. And y equals negative 1. So 1, negative 1 is our ordered pair. Now let's go and try it one more time. Let's take a look at 6x plus 2y equals 4 and 10x plus 7y equals negative 8. This time I'm going to get rid of the x's just because it doesn't really matter if I choose to get rid of x's or y's. Because we did y's on the last one, I'll do x's on this one. I know that 6 and 10 both go into 30, so I need to multiply this one on top by 5 and the equation on the bottom by 3. Now once again, we were talking earlier about how one of these needed to be negative. So this time I'll make the top one negative just to change it up. And we're going to rewrite our equations. So, and then I'm leaving the one on the bottom positive. So net becomes negative 30x minus 10y equals negative 20. And on the bottom we have positive 30x plus 21y equals negative 24. Now if we go to add these two equations together, the x's will go away because they are opposite of each other. 21 minus 10 is 11, and negative 20 and negative 24 is negative 44. We then divide both sides by 11 and find out that y equals negative 4. So as we build our ordered pair, in the y spot, we have negative 4. Now we can go back to the equation. I'm going to take the top one, smaller numbers, no negatives, just makes things easier. 6x plus 2 times negative 4 equals 4. So I have 6x minus 8 equals 4, so I'm going to add 8 to both sides. I end up with 6x equals 12, and then divide both sides by 6 to find out that x equals 2. So our ordered pair where these two will cross is at 2, negative 4. Hopefully you've seen some examples of solving systems by elimination that can help you in learning this skill.